everybody, this is Mrs. Combs. Today we're going to be doing a lesson on prime factorization with a focus on prime numbers and factor trees. So the first thing is a couple vocabulary words that we need to be aware of. A prime number has a factor of only one and itself. So this means that a prime number has only two factors. A composite number has more than two factors. So let's look at a list of prime numbers from 1 to 100. These are a list of prime numbers. One thing to note is that 1 is neither prime or composite. The reason it is neither is because it only has one factor. The only factor of 1 is 1. And to be a prime number, it needs to have at least two factors. So that's why it's neither. And it's also important to note that 2 is the only even prime number. So out of all the prime numbers from 1 to 100, actually out of all the prime numbers in general, 2 is the only even prime number. So this is a list from 1 to 100 of all the prime numbers. It's important to know this because when you're doing your prime factorization, it's going to be the bottom of your list, okay? So it's important to know, am I prime yet? And so we'll talk about that in just a moment. So let's take a look. Let's figure out what factor pairs are. So factors are the numbers that can be multiplied to get another number. So if I'm going to look at the factor pairs of 12, I know every factor pair has 1 in itself. Another factor pair would be 2 and 6. And the last factor pair is going to be 4 and 3. Now I can write these in any order because of the commutative property tells me that 4 times 3 is the same as 3 times 4. Another strategy to figure out all the factor pairs of a number is to use a rainbow method. So I think of the rainbow method as I start at the beginning, so the very first factor of any number is going to be 1, and the very last factor of any number is going to be itself, so 1 and 18. And then I go up from 1 and find its partner. So I say, is 2 a factor of 8? Yes, it is. 18. So what times 2 is going to be 18? It's going to be 9. Is 3 a factor of 18? Yes, it is. So 3 times what is going to be 18? 6. 4 is not a factor, 5 is not a factor, and now I'm at 6. So I have made my entire list, and the reason they call it a rainbow is because when you connect them, it looks like a rainbow. All right, so now that we know what the prime numbers are, now that we know how to find factor pairs of a number, let's figure out how to use a factor tree to make a product of primes. So let's take a look. We're going to use 40. So one example that I use in class is that we know that we can take multiple routes to get to the same answer. So one example I use in class is that sometimes we walk from our house to school and sometimes we take a different route, but either way we end up at school. So I wanted to show you two different ways I can get the product of primes, prime factorization of 40. So on the left, I'm going to start with 4 times 10. Notice how I'm using the multiplication symbol in between the 4 and the 10. On the right side, I'm going to start off with 2 times 20. So let's do the left first, and then we'll go down. So I ask myself, now that I'm on my second row, is 4 prime? Since 4 is not prime, I need to break this down further. So what is a factor pair of 4? I know 2 times 2 is a factor pair of 4. And then I ask myself, is 10 prime? I know 10 is not prime, so I know the factor pair is 5 and 2. I do one last check and make sure my entire last row is prime. 2's prime, 2's prime, 5's prime, 2's prime. It's important to note that I have to put these numbers in order from least to greatest. So I have 2 times 2 times 2 times 5. We're going to talk about the final form in just a moment, but I want to show you how I can start with two different factor pairs and still get the same answer. So if I start with 2 and 20, I can break down the 2 and 20 into further because they're not prime. 2 is prime, so I'm going to bring that down, but 20 is not. So I'm going to use 4 times 5. Now, you could have used 2 and 10. It would have got you the same answer. Again, 2 is prime, so I bring it down. I kind of like string it along. 4 is not prime, so I bring that down to 2 times 2, and 5 is prime. If you notice my last line of 2 times 2 times 2 times 5 is the same as if I started with 4 times 10. Okay, now that I have a product of primes, so these are called a product of primes, and the reason it has that name is because you're finding the product, okay, you're using multiplication, and it's all prime numbers. I have to put it in exponent form. So I ask myself, okay, what's my lowest number? My lowest number is 2. How many of them do I have? 3. So this is going to be 2 to the third power times my next number is 5, and I only have 1. So that's going to be my final answer. So this is a factor tree. Okay, these are factor trees. It kind of looks like an evergreen tree. Okay, and 2 to the third power times 5 is going to be its product of primes. Now I just want to note one other thing. Every line should still get you 40. All we're doing is breaking 40 down into prime numbers. So obviously the first line here is 40. 4 times 10 is 40. 2 times 2 is 4, times 5 is 20, times 2 is 40. 2 to the third power times 5 is 40. You don't have to write this on your paper. You're not going to actually write this at all. But I just want to show you where I'm getting these numbers from and why I know that the product of primes is 2 to the third power times 5. So let's look at another example. Now, what happens when I have bigger numbers? All right. Now that I know how to make a factor tree, I have to think about what happens if I don't know. What happens if I don't know what factors a number has? So I go back to my rules of divisibility. I know my even numbers are divisible by 2. I know the rule for 3, 5, 6, 9, and 10. I know those rules. So use those rules if you're not sure of the factor tree, or sorry, the factor pair for each number. So in number 144, I know it's divisible by 2 because it ends in a 4, but I know that 144 is a perfect square. So I know I can take 12 times 12. Remember, a perfect square means if I can multiply the number by itself to get a number, that's going to be a perfect square. 12 times 12, I can break down 12 into 6 times 2. I can also break down this number into 6 and 2. 6 is not prime, so I need to break that down further. 3 times 2. Don't forget to bring down this 2. Many students forget to bring this 2 down because they see another 2 to the left of it. Then I'm going to break down 6 to be 3 and 2 again. And again, don't forget that last 2. So you can see my lowest number is 2. I have 1, 2, 3, 4 2's. So it's going to be 2 to the fourth power times 2 3's, which is going to be 3 to the second power. Okay? Now when I look at 260, I'm not really sure of the factors. But I know because it ends in a 0 that it's going to be divisible by 10. So I can figure out using either division, or I know that when I multiply any number times 10, I add a 0. So I know 26 times 10 is going to be this factor pair. So I ask myself, is 26 prime? You can go back and check your factor list, or sorry, your prime list. I see 26 is not on this list, so you can break it down. So 26 is going to be 13 times 2. And 10 is going to be 2 times 5. 13's prime, 2's prime, 2's prime, 5's prime. So I'm done, okay? So it's going to be 2 to the fourth power. Sorry, not 2 to the fourth power. It's going to be 2 to the second power times 5 times 13. I added too many 2's. Okay, so that's going to be your final answer here. This is what I would encourage you to do. I have 3 numbers on the board. 32, 75, and 450. You should pause this video and try these problems, okay? Try them, see if you got them. Once you pause them, once you feel like you got them, press play and the answers will appear. So pause your video now to try out these 3 problems. Here are the 3 answers to those problems, 32, 75, and 450. Your tree may look a little bit different than mine, but your answer, the ones that I circled, should be the same. So no matter what route you took to break down 32, you should get 2 to the 5th power. No matter what route you took to break down 75, you should get 3 times 5 squared. And no matter what route you took to break down 450, you should take 2 times 3 squared times 5 squared. One thing that students forget is this multiplication sign, so please don't forget that. That is really important. That's all I have for today. Good luck. Ask me questions in class if you have any. Other than that, have a great night.